Welcome students to our today's lesson. It's a continuation from our previous lesson on the methods of preparing soluble salts. Now, we had already discussed reacting an acid and a metal and given an example and the procedure. We already discussed reacting an acid and an insoluble base and given an example. Now, today we are going to start from the third method, which is reacting an acid and an alkali. Preparation of sodium chloride. Now, this method involves an acid and an alkali being reacted together. The reagents used are sodium hydroxide and hydrochloric acid. The procedure: fill the burette with hydrochloric acid. So the first thing is to fill the burette with hydrochloric acid. Measure 20 centimeters cubed of dilute sodium hydroxide and transfer into a clean conical flask. Now, in the solution of sodium hydroxide, add 2 to 3 drops of phenolphthalein indicator to it and run the acid from the burette into the alkali while shaking until there is a permanent color change. So that is the other step. You run the acid which you've already put in your burette to the alkali which is in the conical flask until there is a permanent color change. Then after that, repeat the experiment without using the indicator, but add the same amount of the acid which you had added earlier. So it's important to write somewhere or note the amount of acid that was used in the first experiment. Then now you repeat the same without using the indicator and use the same amount of the acid. Run the same amount of the acid into the alkali. Then after that, you heat to evaporate the resulting solution to saturation and allow it to cool to obtain crystals of the salt. Now there are points to note in this experiment, and one of them is the reaction is complete when there is a permanent color change. That is when you know that your reaction is complete, when there is a permanent color change. Now, it's also important to note that the purpose of using the indicator in the first experiment is to determine the end point. The end point is the point at which neutralization takes place. When there is that permanent color change, we call it the end point. So in the first experiment, we use the indicator so that we can locate where the end point is. Then after that, we repeat the experiment without the indicator to avoid contaminating the salt. Now, the equation for this reaction is sodium hydroxide plus hydrochloric acid to give us sodium chloride plus water. Those will be the products from that experiment. Now, sodium chloride cannot be prepared using sodium metal and hydrochloric acid. The reason is because the reaction between sodium and dilute acids is explosive and may cause accidents. Yes, it may explode and cause accidents. Now, other salts that can be prepared using the same method are sodium nitrate, whereby you react sodium hydroxide and nitric 5 acid. We have potassium nitrate, whereby you react potassium hydroxide with nitric 5 acid, and potassium sulfate. We react potassium hydroxide with sulfuric 6 acid. These are just some examples. There are others. So these are just a few of them. Now, let us look at the preparation of calcium chloride. This method involves the use of an acid and a carbonate. The reagents used are calcium carbonate and hydrochloric acid. Procedure: Measure about 20 centimeters cubed of dilute hydrochloric acid and transfer into a clean beaker. Add calcium carbonate little by little until effervescence stops. Now that tells you that the reaction is complete. So you filter and heat the filtrate to evaporate it until saturation and allow it to cool for crystals to grow. Now, what are the points to consider in this experiment? Now, one of them is that the reaction is complete when effervescence stops. Calcium sulfate cannot be prepared using calcium carbonate and dilute sulfuric 6 acid because of the formation of an insoluble coating of calcium sulfate, which prevents further reaction between the acid and the carbonate. So, that is a clarification as to why we cannot prepare calcium sulfate using calcium carbonate and sulfuric 6 acid. Now, the reason is because we said all sulfates are soluble except those ones of calcium. And in this case, immediately calcium sulfate will be formed. It is insoluble, so it forms around the carbonate and then the reaction stops because it's an insoluble salt. So that is something to note. Now, the equation for the reaction. So the equation for the reaction is calcium carbonate plus hydrochloric acid to give calcium chloride plus water plus carbon dioxide gas. Now we have other salts which are prepared by this method of reacting an acid and a carbonate, and examples are zinc chloride and copper 2 chloride. So lead sulfate and lead chloride cannot be prepared by the same method because of the formation of coating of lead sulfate and lead chloride that coat the carbonate, preventing further reaction. So we cannot use this method to prepare lead sulfate and lead chloride because we said that the sulfates of lead are insoluble. The chlorides of lead are also insoluble. Therefore, they will form a coating around the carbonate and this will prevent the reaction from proceeding. Now, something to note. Preparation of salts from hydrogen carbonates, which was the fifth method, I believe, follow the above procedure. So hydrogen carbonates will also react with acids to form a salt, water, and carbon dioxide gas. Then it's also important to note that the only hydrocarbons we have are those ones of sodium, potassium, calcium, magnesium, and ammonium. Those are the only hydrogen carbons that exist. The other metals don't have hydrogen carbonates. Now let's move on to the last method of preparing soluble salts, and that is the preparation of salts by direct synthesis. Now, this direct synthesis is also called direct combination of elements. It involves just combining two elements together. For example, when a metal burns in a gas jar containing an nonmetal, the two directly combine to form a salt. For example, preparation of potassium chloride. Now, procedure. Cut small pieces of potassium metal and place them in a deflagrating spoon. Now, after that, burn it briefly and lower it into a gas jar of chlorine. The two will react, forming potassium chloride. So you see, these two elements are just combining directly without a long process. So as long as the metal is hot, then you lower it into the gas jar, then they combine immediately to form potassium chloride. The equation for that reaction will be 2 potassium plus chlorine to form potassium chloride, which is a solid. Now, we have other salts which are prepared by the same method of direct combination or direct synthesis, and we have aluminium chloride. In the case of aluminium chloride, you will just have aluminium in a deflagrating spoon, have it burn for a short time, then dip it into a gas jar containing chlorine gas. So they will combine to aluminium chloride, which is the salt. Methods of preparing insoluble salts. So we are done with methods of preparing soluble salts. Now we move on to insoluble salts. Now, insoluble salts can be prepared by reacting two soluble salts to form one soluble salt and an insoluble salt. This method is called double decomposition or precipitation. So that is the method of preparing insoluble salts. Now, when the two soluble salts are mixed together, the mixture is filtered and the residue is washed with distilled water and then dried. Now, the general procedure of preparing insoluble salts involves mixing two soluble salts to obtain a precipitate, which is the insoluble salt. You filter, wash the residue with distilled water to remove traces of the soluble salt. Dry the residue between two filter papers. So that is the general procedure of preparing insoluble salts. Now, copper 2 sulfate is a soluble salt reacted with sodium carbonate, which is another soluble salt, and that's why their states are aqueous. We form copper carbonate and sodium sulfate. Now, the copper carbonate is the insoluble salt. So that is the one which now you filter. When you filter, the soluble salt, which is sodium sulfate, will pass through as a filtrate, while copper carbonate will remain on the filter paper as a residue. Then wash the residue. It involves just pouring distilled water on top of the filter paper. That way you wash away any traces of the soluble salt which could be on the insoluble salt. Then you dry the salt between two filter papers. You scrap it from the filter paper and place it onto dry filter papers. Then you dry it. Now, other salts that can be prepared by this method are barium sulfate and lead 2 sulfate. Barium sulfate and lead 2 sulfate. Those are just examples of other salts which are prepared by the double decomposition method or the precipitation method. Note the following. Questions on insoluble salts in an exam. Roman 1. In a setup where the starter reagents are a metal or a metal oxide, first convert the metal or metal oxide into a soluble salt by reacting it with dilute nitric 5 acid. So if in an exam you are told, prepare an insoluble salt given the metal or the metal oxide, the first thing to do is to react it with nitric 5 acid to make it a soluble salt. Now the reason is all nitrates are soluble. Therefore, when you react it with nitric 5 acid, it becomes a soluble salt. Then, to get the insoluble salt or an hydroxide, add a salt of potassium or sodium. Why are we adding a salt of potassium or sodium? Because salts of potassium and sodium are soluble. So, then after you react the two, because now you are reacting two soluble salts, then filter and wash the residue with distilled water and dry between two filter papers. Now, another thing to note is that when the starter reagent is a metal below hydrogen in the reactivity series, a metal like copper, you first burn the metal in air to form its oxide. For example, you burn copper in air to form copper 2 oxide, then react with the dilute acid. For example, how to form lead 2 sulfate starting with lead. Add excess lead metal to dilute nitric 5 acid to form lead nitrate. That is the first soluble salt. Filter to remove unreacted lead and obtain lead nitrate as the filtrate. Then add sodium sulfate solution to the filtrate to precipitate out lead sulfate. Then filter to obtain lead sulfate as a residue. Wash it with distilled water and dry it between 2 filter papers. And then you will obtain your dry lead 2 sulfate. Now that marks the end of our lesson. Hope you've been attentive enough and you have been able to understand every point. Let us meet again in the next lesson. Cheers.